In principle, alkene can be, as you can see in the slide, in the chapter 8, it can be converted by reactions into many different functional groups. And all of these are addition, remember that, addition reactions. You follow me? So alkene can be converted in principle to many other functional groups by addition reactions, or sometimes actually by oxidation. Anyway. All right. Now, how we make alkene in principle. So synthesis of alkene, or sometimes we may refer to this topic by preparation of alkene. Always the synthesis or preparation, it means in organic chemistry, means converting a functional group into another. How to convert a functional group into another. You follow me? All right. Now, in principle, alkenes can be prepared, or the methods of preparation of alkenes from alkyl halides by elimination in presence of, I'm just going to use the same with heat. In presence of strong base with heat, we can always convert alkyl halides into the corresponding alkene. So this is elimination of alkyl halides. We will come to this later on in chapter 11, how about this reaction and the details of this reaction. But this is just to know what's the method used to prepare alkenes. Alkene can be prepared from the corresponding, or one way to prepare the alkene from elimination reaction of the corresponding alkyl halide. Always the elimination here, it includes alkyl halide in the presence of alcohol. Or it can be also prepared by dehydration of the corresponding alcohol. The second method, so this is the first method. Second method is dehydration of alcohols. And the dehydration of alcohols, for example, if we took this tertiary tertiary alcohol, we allow it to react with strong acids such as sulfuric acid. What we are going to get the corresponding alkene. Now, as you can see here, we say dehydration of alcohol. Dehydration means always, whenever you hear D, means minus. Hydration, always we refer to the water, which means this reaction will include the removal of water molecule, which means the elimination of water molecule. And as you can see here, it will be the removal of this OH with one of the hydrogens in here to form this alkene. Is that clear? This is the second method for the preparation or the synthesis of alkene, which is the dehydration of alcohols. Now, in this case, as you can see here, we do have different possibilities of the alcohol formation here, for the dehydration, because we said it is minus H2O, but the OH, it's obvious that we will have OH to be removed or to dehydrate it, but there is a hydrogen now. Which hydrogen has been removed? As you can see, this hydrogen has been removed to form that product. But what about this hydrogen? It can also make the double bond in here. In other words, why not? It should form, for example, this alkene. And the removal of the hydrogen, the OH will be of one hydrogen, or the OH and one hydrogen from this carbon. Do you follow me? And sometimes for this reaction, there could be different possibilities for the removal of the hydrogens. In principle, according to a rule here in organic chemistry, what we call it Zaitsev rule, this is chapter 8. We're talking about chapter 8, guys. This is chapter 8. Do you follow me? Now, in principle, there is a rule in here which is called Zaitsev rule. I'm just going to see it in here. In principle, the more substituted alkene will be formed in higher yields. Always. For the dehydration of alcohol, when the alkene becomes the product, which will be the alkene which is more substituted will be in higher yield. As you can see here, let me just explain to you the number of substitution, as you can see. Now, for this alkene, how many alkyl groups surrounding the carbon double bond carbon in this case we have? Which, first of all, you have two alkenes. You have alkene number 1 and alkene number 2. First of all, which of the two alkenes is more substituted according to the rule, in order to understand it? Which of the two alkenes is more substituted, number 1 or number 2, and why, of course? I'm waiting your response, guys. Anyone? Why number 1, Hajar, why number 1 is more substituted? What does it mean, actually, more substituted? We refer to more substituted, which is simply the number of alkyl groups, which are carbon atoms attached to carbon double bond carbon system. Which one is more substituted? Structure number 1 or 2? Of course 2, because as you can see here, you can see the carbon double bond carbon system here. This is the system here which we are talking about. This and this. These two carbons. Do you follow me? How many alkyl groups, or in other words, carbons, attached to the system? We have 1, 2, and 3. Do you follow me? So this is called tri-substituted. Do you follow me? Isn't it? Right? Now, for this system, how many carbons are attached to the carbon double bond carbon system? So we have carbon and carbon. So we have this carbon and this carbon. Now, as you can see, how many substituents, how many alkyl groups? We have this group, we have this group, and that's it. So this is called di-substituted. Isn't it? Right? So we have tri-substituted, we have di-substituted. According to the rule here, always the product which will be more substituted will be formed in higher yield. In this case, that one will be the major product, and this one will be the minor product. Do you follow me? Because the more substituted the alkene, it will be formed in higher yield, and it will be actually more stable. Of course, if you ask why, do you follow me? If you ask why, it's all about the previous rule, what we have discussed in the chapter 8 before, when we compare the stability of the alkene, we said as the number of alkyl groups attached to the system increases, the stability increases. It's due to the stability of the alkyl groups, of the alkene, I'm sorry. As number of alkyl groups attached to carbon double carbon system increases, stability increases. Why is that? Due to hyperconjugation, which we have already explained it in the previous lecture. Do you follow me? The rule here which specify the preference of the more substituted group, we called it side-safe rule. Side-safe rule. And that side-safe rule is specifying like this: the alkene which will be formed in higher yield from the dehydration of alcohols will be the one which is more substituted. But okay, don't worry about the picture now, because the video will be uploaded in YouTube. You will see it much better. But now, focus please. If there is any question now, it's better actually to interact with me. You will see it actually in more details on the YouTube. Yes, please. Would you please repeat your question and then get it fully?
In the minor structure.
Yes.
From when the double bond?
Because it's dehydration. Do you see here? This is actually a method for preparation of alkenes. It's called dehydration of alcohols, which means we will have elimination reaction. We should hydrogen from another carbon. Do you follow me? Now, here we have this OH will be eliminated from this carbon. You follow me? So you need another hydrogen to be eliminated. It's either this hydrogen to produce the major or that hydrogen to produce the minor. طبعا, when we eliminate the OH and hydrogen, instead of these, there will be a formation of carbon double bond carbon. Do you follow me? Taif? Is this Taif for who asked, or?
No, Hager.
Hajar. All right, Hajar. Is that clear, Hajar?
دكتور يعني هو يعطونا مركبين مقصود هنا الماء الميجر والماينر.
It's first of all you have to understand this. This is a method for preparation of alkenes. One method for preparation of alkenes, it's simply from dehydration of alcohols. From alcohol we can convert it to alkene by presence of acids such as sulfuric acid. Now, here we have two possibilities. Let me just give you another example, Hajar, and for everyone else, and then it will be becoming clear. All right. Let me just give you the reaction in the scheme here. For example, we have CH3, CH2, CH2, then C, OH, then CH3, then CH2, CH3. And you allow this to react with sulfuric acid. Do you follow me? Is it? Alright. Now, as you can see, as we have said, this is simply a method for converting alcohol to alkene. How? By dehydration. What does that mean? By elimination of water molecule. Where this water molecule will come from? One of the carbons which is attached to the OH, this OH will be removed, and one hydrogen from the adjacent carbon will also be removed to form to make the elimination of water. يعني in other words, the summary of the reaction, it will be elimination of water or removal of water molecule. Where this water molecule will be removed from, as I said, part of the water molecule will be coming from the OH. The other part, the hydrogen, will be coming from the adjacent carbon. Where are the adjacent carbons? Either from this carbon or this carbon or this carbon. Do you see? Can you follow me?
Yes, yes, doctor.
So, how many alkenes are possible from this reaction then will be for this reaction? How many alkenes? Three. Either the double bond will be here or there or there. Well, let's simply write them all. Let's simply write all possibilities. And let me just indicate the possibility by writing number. So this is possibility number 1, possibility number 2, and possibility number 3. So possibility number 1, the alkene here, CH3, CH2, CH. Now I'm just going to use another color just to indicate that the double bond has been formed here. Double bond now, and then carbon, then CH3, then CH2, CH3. This is simply the first possible product, isn't it? Or the first possible elimination or dehydration product. The second will be, let me rewrite it again here, for example, will be CH3, CH2, CH2, carbon, double bond, CH2, and then CH2, CH3. This is the second possibility. The third possibility, the carbon, double bond carbon will be between these two carbons, and therefore we will have CH3, CH2, CH2, then C, double bond, CH2, CH3, and then here we have a CH3. I'm sorry. We have here a CH3. Do you follow me? Can you see all the three possibilities?
Yes, doctor.
So we have three possibilities. According to the Zaitsev rule, which one is the more stable? Which one first will be the major, which is again the same question. Which one will be the more stable one?
I think
They are what?
the same.
Why?
No, doctor, the third one, I think.
Why? Yeah, always.
We have to alkyl group.
Now,
And
the
we have one just.
as we have explained, if you refer back to the previous lecture, we have explained the stability of alkenes. We said the more substituted alkene, the more stable it is. Yani, as the number of alkyl groups attached to the carbon double bond carbon system increases, the stability will increase. Do you follow me? Here, how many alkyl groups attached to this carbon double bond carbon system? How many? Two or three? No, it is three. Why?
Why?
Because this is alkyl group, isn't it? You just focus on the two carbons. Very simple, right? So this is one alkyl group, this is another alkyl group, and this is another alkyl group, isn't it? Is that clear?
Yes, doctor.
Are you sure? So this is tri-substituted alkene. In the structure number 1, how many alkyl groups are there, ya Jama'ah? How many? In the structure number 1.
Two active groups.
Why 2? Why 2? Why it is difficult to recognize it? It's very simple. It's a piece of cake. You just check the 2 carbons which making the double bond. So this carbon and this carbon. And count now the number of alkyl groups attached to these 2 carbons. How many carbon atoms, let's say it. How many carbon atoms attached to these 2 carbons? How many? The total.
3.
Yes, very obvious. Straightforward. So this is 1, 2, 3. So this is again tri-substituted. Do you follow me? What about the structure number 2? How many alkyl groups attached to structure number 2? Exactly, 2. So this and this. So then, according to the Zaitsev rule, we said the alkene which is more stable is the one which has higher number or which is attached to more substitution. You can see structure number 1 and 3, they have similar stability, and the least stable structure will be number 2, and therefore we should expect that the yield of the reaction will produce 1 and 3 in higher yield compared to structure number 2, because structure number 2 is the least stable one. Do you follow me?
So can we say that the 1 and 3 is the major and the 2 is the minor?
Exactly, absolutely. That's exactly what we should say. Now, 1 and 2 are the major products. It's like a mixture of products. Major, and this is simply a minor. Now, as you can see, in principle, we have 3 possible structures. But what if I asked you, how many E and Z structures also possible? How many stereoisomers E and Z possible? Is there a possibility for E and Z here? Is there a possibility for E and Z? Yes or no? Yes or no? Is there a possibility for E? Yes, of course. لأن بكل بساطة we have 3 different atoms or groups attached to the carbon double bond carbon. So there could be E and Z. So there are 2 possible products of this. Here, is there a possibility for E and Z?
Yes.
Yes, again, because again it's attached to 3 different groups or atoms. Here, is there E and Z possibility for structure number 2? Is there E and Z? Why, Hajan, there is no E and Z in this structure, in structure number 1? Why? Yes, true, but what you can say, as we have explained when we talked about E and Z, this carbon is attached to 2 same atoms. Whenever you have one of the carbon double bond carbon system attached to 2 identical atoms, then there is no E and Z, or there is no cis trans. So here there is no E or Z, but here there is E and Z. There is here E and Z, but in this case there is no E and Z possibilities. Is that clear, guys? Any question about it? Is there any question? Alright, let's move to another reaction of alkenes. Now let's talk about reactions of alkenes. So what we have discussed so far in the beginning of chapter 8, we have discussed the preparation methods of alkenes, or in other words, how to make alkenes. I just would like to highlight something. Whenever you hear synthesis or preparation, it means functional group, how to converting a functional group into another. Do you follow me? Yani whenever you heard the word synthesis or preparation, it means how to convert a functional group from one to another. In other words, when you say synthesis of alkenes, it means how to prepare alkene from another functional group. Do you follow me? That's always the case, just in order not to have any ambiguities. Now, reaction, whenever you hear reaction, it means, again, similar words, but simply in another concept, which simply, again, functional group, converting a functional group into another functional group is simply, again, another terminology which we use as synthesis. Let me talk about reactions of alkenes, how to convert now alkene into another functional group. So, reactions of alkenes. The other second type of reaction which we discussed today, اللي هو halogenation of alkene. And halogenations, from its name, always focus on the title of the reaction. Halogenation, it means addition of halogen, and the halogen we always refer it by X2 to alkene. So it's all about addition reaction, and this is here, it's addition of halogen to the alkene. This is one of the most important reactions in organic chemistry, this reaction used as chemical test for unsaturation. You know, the unsaturation below the presence of a double bond or triple bond in a compound. We will see how and why. In principle, if we take, for example, cyclohexene, if we allow cyclohexene to react with bromine in presence of a solvent such as CCl4, what we're going to get, we are going to get addition reaction of this alkene. We will get 1,2-dibromo cyclohexane. Now, why this reaction is very famous reaction? Because simply the color of the halogen in here, the bromine color, is some degree of red to brown color. You follow me? It's very clear, very characteristic, very distinct color. You follow me? When the reaction took place, the product here is colorless, which means if the reaction proceeded, the red to brown color will be converting into colorless color. Or in other words, the red or brown color of the bromine will disappear. This change in the color, that's actually what we use it as a chemical test for unsaturation. Do you follow me? So halogenation reaction is used as a chemical test for unsaturation because simply it will the red or brown color of the bromine specifically will be converted into colorless reaction. Is that clear, guys? Is there any questions so far? Now let's talk about the mechanism of the reaction. let's talk about the mechanism of the halogenation reaction. Our stereochemistry, first of all, and then talk about the mechanism. Halogenation reaction is or simply produce halogenation reaction. Halogen adds in anti-manner or fashion. What's the meaning of anti and what's the meaning of sen? We do have two types of addition or two types of addition reactions. Either we have sen or anti. What's the meaning of sen and anti? Just a second, please. Now imagine, just to show you easier now what I mean by anti and sen. Imagine that this here, what I'm holding, is carbon double bond carbon. So we have carbon double bond carbon system. Do you follow me? Now we have addition reaction to this side here. The addition means we have two parts will add to these two carbons. Do you follow me? Is that clear so far, guys? Are you following me? What I mean?
Yes.
Perfect. Now, these two parts, I'm just representing them with two colors, the red and the green. Now, we do have two possibilities for the addition regarding the stereochemistry. Either the adding part will add themselves from one phase or one plane. In this case, we call this addition or this fashion of the addition, we call it sen addition. Or the other possibility is that the two adding parts, they add themselves to the carbon double bond carbon from two opposite planes. In this case, we call it anti-addition fashion. Got it? Can you recognize now the sen addition compared to anti-addition? Sen, anti. Sen, anti-addition. So, as I said, there are two possibilities for the two adding parts to add themselves to the two carbons, which makes the carbon double bond carbon. They are sen or anti. In this case, in the sen fashion, the two adding parts add themselves from same plane or phase. While in the anti, it's opposite. The two adding parts add themselves from or to add themselves to two opposite planes. This has consequences, guys. This will simply determine what we call it the stereochemistry, because that's actually sen most likely will lead to formation of a cis product if we refer to, in other words, if the two adding molecules or two adding parts add themselves from the same direction, from the same fashion, that means we most likely going to get cis product. If they are adding themselves from opposite directions, most likely we are going to get trans product. Got the point, guys? So that actually has a direct consequence for or to the stereochemistry. So that's actually the whole issue, and this is always, remember, when we talk about syn and anti. Here in the halogenation reaction, it's always adds in anti fashion. So remember this. Halogenation leads to anti-addition reaction. In other words, let me just refer back to the previous example. In the previous example, we had cyclohexene reacting with bromine in presence of CCl4. According to what we have said, we said the halogen will add itself in anti-fashion. What does that mean? Now, what are the two adding parts of the Br2? What are they? When you have Br2 reacts as addition reaction, what are the two adding parts of the Br2? Waiting for your response, guys. Yeah, two Br atoms. Do you follow me? So in other words, one Br will add from above the plane, one Br will add from below the plane. In other words, we're gonna get a trans fashion. So either we represent it by this way, Br, or we may represent it this way. Either way, Shani, either this or that, it's the same. Do you follow me? The most important thing, as you can see, regarding the stereochemistry of the product, that the product in this case must be trans, because simply the addition was anti-fashion addition reaction. Is that clear, guys? Is there any question about it?
Repeat, please.
We said for the halogenation reaction, halogen acts in anti-fashion. The one who asked, what's the meaning of anti-fashion? We have just explained it. What's the meaning of anti-fashion?
Two added parts in the opposite ends.
Wonderful. That's wonderful. Here we have the alkene, right? Alkene is a planar system, right? Isn't it? Which means the two adding parts, remember the two bromines, one from the above and the other one will be from below. Do you follow me? They can't be from the same phase, because simply this addition always anti-fashion or anti-fashion addition reaction. So that's why the product will be, what do you call the product here? What's the name of the product in this case? What's the name of the product? Yeah, it's 1,2-dibromocyclohexane. Like in order for your answer to be correct, you must specify the stereochemistry. What about the stereochemistry of the two bromines at the cyclohexane system? Are they from the same phase or they are opposite phases, Zainab? Huh? They are trans. So that's why we need to specify that the correct name of this compound must be trans, then 1,2-dibromocyclohexane. Is that clear, guys?
Yes, doctor.
Is there any question about it?
No.
All right. Now let's talk about a little bit more details about the mechanism of the halogenation reaction, and then we're gonna stop actually at this point. So let me just talk about more details about the mechanism of halogenation reaction. Mechanism. Of this halogenation reaction. Now, whenever we have a carbon double bond carbon, you follow me, and then we have a bromine to react here. Remember that this is the Lewis structure of the bromine. What we are going to get, intermediate product where the lone pair here will be given to this carbon, and this double bond will be made to make a bond with the bromine, and this bromine will leave. So we are going to get this bridging compound where we have the bromine as bromonium ion in this case, plus Br minus. This is what's going to happen. You follow me? One of the lone pairs of the bromine will be used to make a bond with this carbon, and this bi-bond will be used to make another bond with this bromine. Then the bonding electrons here will be given to the bromine, and then we are going to get here what we call it bromonium ion bridge. Bromonium ion bridge. It's like a bridge actually in this case. Do you follow me? So this is the first step in the mechanism of the reaction. Now let's see why we have anti-fission addition reaction. Now the Br should add itself from two directions, either from this direction or from this direction. Which direction you think would be preferred? The first direction or the second direction, and why? Which direction should be preferred? The Br to attack from below the plane, or from the same plane where the bromine, the first bromine should be? Shayma, why? Why the second direction is more preferred? So what? So because it's trans. So what? Why it is the trans is more stable, or why it is more preferred? Okay, opposite. So what opposite?
Maybe less attraction.
To avoid Ahmed al-Ajmi is perfect. To avoid the repulsion, absolutely. لأنه بكل بساطة, if it adds from the same phase, there will be a repulsion between the bromine and the bromine, and each one has a bigger size. So that's why this direction is preferred, while this direction is not preferred. So when this attacks from here, this goes there, and that's why we got here, we will get like Br and then Br. It's like anti-fission reaction. Do you follow me? That's the reason behind it. And of course, in this case here, because as we have explained before, this system, there is a free rotation, it may not affect, you will not get access a trans here. But for the previous reaction, when we had a cyclic system, there is no free rotation, therefore the steric chemistry of the product will appear very clearly. Got the point, guys? Is there any question about it?
دكتور
Yes, please.
الحين ليش الكربونتين مطبقات بنفس البرومين بالخطوة الثانية؟
يعني this is simply the intermediate, what we call it. يعني this is, you mean this one, the bromonium ion bridge, right? It's like the intermediate. It's the something in between which will lead to the reaction. So the first step, this is what we have found actually in the mechanism, that one of the bromine atoms will add itself from one plane, one side of the plane. Then the other bromine now will attack this bridge or this intermediate. So there are two possibilities, either from the same plane or from opposite plane. Very obvious that the second bromine should attack from the opposite plane in order to avoid repulsive forces. Do you follow me? All right. I think it's enough for today. We will continue the next lecture. Most likely we will skip the lecture today. Today in the afternoon we are not going to take extra lecture. We will take the extra lecture next week, because next Monday we will have two lectures. the normal lecture in the morning, and as I said, the second lecture will be in the afternoon. Today there is no afternoon lecture. You are free to go. Is that clear?
دكتورنا لابات الفصل
ما سمعت. بالنسبة لللابس هذا الأسبوع ما في لاب.
والأسبوع الجاي بعد
ما راح يكون على الأسبوع القادم، يعني لغاية ما نخلص، يعني بس بعد الأسبوع القادم إن شاء الله بنعطي 2 labs together as in the previous lecture, as in the previous time. So don't worry about the labs. The labs will be the next week. There will be no lab 2. The week after there will be 2 experiments together. Is that fine? I just would like to highlight the importance to solve the assignment. I have already, if you have seen it, in the Moodle, I have uploaded assignment for the stereochemistry. I would recommend everyone to do it as soon as possible in order, to make sure that you are understanding all aspects of the stereochemistry which we have explained before. Clear? Yes, please.
You got it really that we should submit it at Monday. Can you please do Wednesday? Expect the
if I delayed under Wednesday, some of you will ask, okay, would you make it until the next Monday? First month. It's okay, no worries. But just to make sure that you study as soon as possible and don't delay. This is the most important thing. Already we started up in chapters, chapter 7, chapter 8. Now you will forget the stereochemistry later on if you delay. It's fine for me. I can do it next. Okay, it's fine. It's all right. I will do it. So it will be delayed until Wednesday. That's not a problem. But what I mean, just try to do your job as fast as possible in order not to make you forget what you are studying. Is that clear?
المادة تعتمد على الفهم، فما بننسى إن شاء الله.
إن شاء الله، إن شاء الله، كل التوفيق إن شاء الله. Alright, thank you so much. ما سمعت عفوا. طيب يلا بالتوفيق إن شاء الله. إذن, as I said, today there will be no other lecture in the afternoon. Inshallah, I'll see you next Monday. Good luck, guys. Alright? Yes, please. طبعا الاساينمنت it's part of the assessment, of course. There will be marks on it. We will have another maybe 4 or 5 assignments before the end of the course, and all of these will be part of your assessment. So as we said, we will have 15 for the first, 15 for the second, 10 for the lab, and then where there will be another 10 for the assignments. Is that clear?
Yes,
All right. I wish you a very nice, pleasant day. مع السلامة. السلام عليكم.